Welcome back, fellow chemists. This is part 2 of this chapter on stoichiometry. We are looking at limiting and excess reactants. Sounds like a very fancy term, or a couple fancy terms, but the words almost say what they are. So an excess reactant is what you're going to have excess, the one that you won't run out of, and the limiting one is the one that you will run out of. It's going to limit how much you can make. So going back to this recipe at the very beginning, we can focus on the 2 cups of sugar and let's do 3 cups of flour. Yep. Well, if we have 2 cups of sugar and 2 cups of flour, then of course the 2 cups of flour is the one that we're going to run out of first, because we really need 3 cups of flour. So the 2 cups of flour is going to limit our reaction. Right? Now, if we have, let's say, 100 of each, then we are going to still run out of the cups of flour, because we need a whole lot more flour for the cake than we do the cups of sugar. Now, as we did before with stoichiometry, we can also change it to grams. For instance, if we have 2 grams of butter, and we don't have to choose 2 grams of flour, we can choose 80 grams of flour. We can really choose any amount of anything and find out which one we're going to run out of first. So whether you're making a car and you have 4 tires, or a cake, or doing a chemistry equation, there's always going to be something that you're going to run out of first, or something that you're going to have excess of. It'd be great if we never had one that we ran out of or one that we had excess and they both were perfect, and it's just not quite realistic in chemistry. So we're going to do some actual equations now. Now if we look at this very simple balanced equation, we have a 1:1:1 ratio. So 1 mole of one plus 1 mole of another makes 1 mole of product. So if we have 2 moles of C and 2.5 moles of O2, well, it should be pretty easy to see that the moles of C is going to limit our reaction, and the 2.5 moles of O2 is going to be in excess, because, well, we simply have more of the O2 and we're supposed to have the same amount. So limiting in excess is sometimes really a simple thing to see. However, sometimes the balanced equations, well, usually they're not that simple. This time we have a 1:2:2. So we might have to do a little bit more thought into which one's going to be limiting and which one's going to be excess. In this case, we just randomly chose 2 moles of oxygen and 3 moles of H2. And when we look at our answer, we would have excess of the one that we actually have less of. Okay. Now, of course, you might have to do a little bit of math, a little bit of stoichiometry to do this, and that's what we're going to do with this next problem. So now we have this balanced equation at the top, and we can see our coefficients. We don't see a number here, but technically it's a coefficient of 1 and 4, and there's a 1 and a 2. And the problem, they give us 2 moles of one and 1.5 moles of the other. Now, this is essentially 2 stoichiometry problems. So whenever you're doing a limiting excess, you're doing twice the work to get one answer. So I'm going to write 2.0 moles of HF. That's going to be one chemical that I'm given, and I'm also given 1.5 moles of the other chemical, the SiO2, silicon dioxide. So I'm going to just kind of do these together. So on both of them, it's fortunate that I started off with moles. So it's exciting. I can do the magic step right away. So I'm going to put moles of HF down here, and I'm going to change them both to a product. The nice thing about this is it really doesn't matter which one I choose. I'm going to choose water because water is a great chemical, but you could do it either one and you would still get the same answer. So moles of HF, the coefficient is a 4. Get that from right here. And moles of H2O, I'm going to put a 2 here. And so I would do 2 times 2 is 4, divide by 4. I would get 1 mole of water if I started with 2 moles of HF, since those cancel. Okay, down here, on the other hand, if I had 1.5 moles of silicon dioxide, well, I'm going to put this is my magic step. This time I'm going to have moles of SiO2 on the bottom, and I will have moles of, it only makes sense to choose the same product, moles of H2O. And I get 1 mole of SiO2 because that's what it said up here. And then again, I'm going to use my 2 moles of H2O. So the units cancel, and 1.5 times 2 gives us 3 moles of H2O. So from this, if I'm given 2 moles of one and 1.5 moles of the other, this one is going to produce less product. Okay, so we're going to call this our limiting, and of course that means this one would be our excess, and more specifically this chemical would be the excess, and of course this chemical specifically would limit the reaction. So we can do many more problems. We can change it from grams to moles to grams. It's not necessary to go beyond moles of H2O, because in both these cases, if we did change it to grams, we would just do one more step, and mathematically it would make both of them proportionally the same. So it only makes sense to stop at moles. And if we had chosen Si4, if you'd like to, you could try it yourself, but you would come up with the exact same answer for which one is limiting and which one is excess. So we're going to finish with one more stoichiometry, limiting versus excess. And again, we know that we're going to have 2 different problems. We're going to start off with this many grams of that and that many grams of that. So it's just like any recipe. We have 45.5 grams of HF and 25.0 grams of SiO2. Okay, so starting off with grams, so we have to do a little bit more work to get to our magic step in both of these. So I'm going to take grams of HF down here, and I'm going to put moles of HF up here. Now remember, I can only use 1 for moles because I am not ready to do the magic. And fluorine weighs 19 grams, so 19 plus 1 was give us 20 grams here. And now we can do our magical step. And we'll eventually do it for the one at the bottom. So HF, our coefficient for HF is 4. So 4 moles of HF. And this time, let's change it to the SiF4. So we have 1 mole, that looks awfully sloppy, let me do that. 1 mole of SiF4. Okay, so we would do that to find out how many moles of SiF4. And then we can also do this chemical equation down here. We're going to have grams of SiO2 and 1 mole of SiO2. So this weighs 60 grams. You add up 1 silicone and 2 oxygens, you get the grams from the periodic table. So we get rid of grams. Okay. Now we can do our magic step. Yippee! We're going to use 1 mole of SiO2 down here. We got that from our coefficient. And then we're going to change it. We have to change it to the same product. So we're going to put 1 mole of SiF4 up here. Okay. So in both cases, we're going to end up with moles of SiF4. I know that last time we chose a different product, but mathematically it doesn't matter if we had chosen H2O or SiF4. So we put in our answers. We have 0.569 and 0.417. We got that by multiplying the top numbers and dividing by the bottom numbers. So it looks like this one is our low answer. And of course this one would be excess. So our limiting is going to be this chemical, the SiO2. Maybe it would be nice if we were given more to start with. And our excess would be this one right here. We were given a bit too much of it. Okay. So if I was given both of these amounts, this is really what's going to happen. I'm going to have this many moles of SiF4. We can't possibly have this many moles of SiF4 because of our limiting reactant. We'd have to have more in order to produce more. So there are many variations of doing this. We can go from grams all the way to grams, which would be unnecessary. Stopping at moles is perfectly fine. But we can also do more with this 0.417 moles. Since we know that that is the actual number that's going to happen, we can change this into how many moles of water we would need to produce that amount. We could change that to how many moles of HF we would actually need to produce this amount. So once you find out the limiting number, that's what's actually going to get used. You can change it to any one of the chemicals in the balanced equation. So hopefully you can see how limiting and excess is a very practical use for all sorts of chemistry processes, and even cooking and baking. So thank you very much for watching. If you look up limiting and excess on YouTube, you will find others that show it. And if this didn't make sense, try replaying mine or watching a few others. Thank you again, and good luck.